Now at the beginning of this objective, you saw some specific examples of taking roots of numbers raised to a power where the power and the index were the same. So based upon those observations, let's make some generalizations now. That the nth root of a to the n will equal a if a is positive and the root or the index is odd or even. Second generalization, the nth root of a to the n will be equal to a if a is negative and the index or root then is odd. Now in the case where the index is even is where we have to be careful. If we have the nth root of a to the n and a is negative but n is even, we want to be sure that the result is positive. So to ensure that, then we need to put absolute value signs around the a. So armed with these generalizations, let's next consider some specific examples where we have roots of variables raised to powers. And for the first one, we're going to look at the ninth root of x to the ninth. Now because the index is odd, we can simply write in this case x. We're not concerned with absolute value signs. Now in our next case, the eighth root of x to the eighth, we want to be careful to ensure that the result is always positive. Now in this case, we don't really know whether x is going to be positive or negative. So we'll be required then to put absolute value signs around the x to ensure the result is positive. Now in the next example, we have then the cube root of x to the ninth. And what we would like to do first then is to rewrite x to the ninth as x to the third power. And so the x to the third here inside will operate as the a does in the generalizations above. So again, because the index or root is odd, we don't need to be concerned with absolute value signs. The cube root then of x to the third, quantity to the third, we can write then as just x to the third. Okay, the next example, again, we need to be careful because we notice the index is even. So we'll rewrite x to the eighth as then x squared to the fourth. And again, the x squared will operate as the a does in the generalizations above. So if we have the fourth root of x squared, quantity to the fourth, we want to be assured that the result is going to be positive. So we first look at x squared, and since x squared will always be positive, we don't need to put absolute value signs around it. And so we're finished.